Hello, and I'm talking to Piyush Savalia, who's EVP for marketing for SiTime. And Piyush is going to talk about the latest chorus products for automotive that SiTime are launching this week. Piyush, hello.
Hi, good to see you again after, I guess last time it was in Germany, huh? A few months ago.
Yes, we met at Embedded World, and you told me about the new chorus clock generators that you launched there. We're meeting today just because you've launched an update to that specifically for automotive, and I think putting in a little bit of context, there's this whole sort of drive towards software-defined vehicles and the electronics, and I think we've written about it a lot, but um, that sort of mean that has implications on timing, but also you can explain to us a little bit about what you've got as a product, but why that's necessary.
Sure. So yeah, what's going on in the industry, as you know, is people want software upgradable vehicles, just like their phones and all that stuff. And so the car architecture is changing fundamentally. With previously, it was just all these microcontrollers spread out all over the car, and now it's much more structured with different domains and zones and things like that. And of course, the amount of electronics in cars is increasing because of all the functionality that we are adding. Now, the more electronics you need, the more timing you need. And rather than putting discrete components for each timing device, we've been working with a few customers who said, could you integrate all of this into a single device? And that's how we came up with this Chorus clock generator.
Mhm.
Another thing that customers wanted was some kind of monitoring function so that they could detect faults and all that much earlier so that they could take care of it or shut the vehicle down or whatever it might be. And so we incorporated some technology called fail-safe technology, our term, which gives the customer the monitoring functions and things like that. So that's what we are introducing. It's a follow-on product to something we introduced 6 months ago for the comms enterprise data center market.
Okay, it's a clock generator with multiple outputs, and it's got a dedicated GPIO high priority interrupt capability to the MCU, and it's got that those monitoring features. Maybe you can just outline some of those and why they're important.
Sure. So the guts of the device, you have a phase lock loop. You need that to create clocks out of it. You have got a MEMS resonator integrated inside instead of a discrete device like it used to be the case with quartz. And then we've added four outputs so you can drive different things in the system. And what we've added in addition to that is a serial I/O so that you can read all these monitoring functions serially or external pin so that you can route that as a high priority interrupt to the MCU. The Putting all this together in one package is something unique, we believe, especially the fail-safe monitoring functions, which is needed for automotive. So that's in a sense it. It can generate frequencies from 1 to 220 megahertz or so, different kinds of outputs and things like that. But that's pretty standard in most clock generators. The monitoring functions, there's a whole bunch of things. You can detect if the PLL goes out of lock. You can detect if there's a memory fault. You can detect if there's a IO problem, temperature problems, things like that. All those things are incorporated into the device.
Basically, what you're saying is you're also reducing the bill of materials, but also the versatility of the device.
Yeah, and the story around all of this is integration, right? I mean, it gives you the benefit of things working in sync internally together, gives you the benefit of lower area, up to 30% lower area, if I remember correctly. Uh, Gives you the benefit of something that is not, people don't think about it all the time, but in a high, in a system with a lot of electronics in it, you got to make sure there are no noise sources that could interfere with the operation of the system. And when you integrate the devices, the different timing components into a single chip, you eliminate those kinds of things too. For example, we've integrated the resonator. Okay, what does that do? It eliminates any kind of pickup that you might have if you were using an external discrete resonator and the traces were long, you might get pickup on that. We eliminate that. So it just simplifies the design work for the customer.
One of the things that you talk about in your blog is about reducing clock tree complexity. What does that mean?
Yeah, so for example, if you have in the system a microcontroller or a microprocessor, you have Ethernet for transmitting data across different places. You've got some memory devices in there. You've got some LiDAR sensors in there, or things like that. They all need discrete clocks. Our device has four outputs. Integrate the clocks for all of those, drive it from a central place to all these different devices, and suddenly you've eliminated a whole bunch of area and you don't need to use discrete devices. You get a simpler supply chain management because you're dealing with one versus four different suppliers. Those are some of the benefits that we give.
But just tell me a little bit about the fail-safe technology.
Sure. It's basically monitoring functions that we've built into the device. So that if there is a problem with the clock, which a clock is the heartbeat of the system, if there's a problem with the clock for whatever reason, external interference or temperatures become too high or whatever it might be, if there's any kind of problems, flag is raised saying, hey, there's a problem here, so that the system can take appropriate measures. Whether if there is redundancy, you shift to the redundant system. If there is redundancy, but the whole system is impacted, you could shut it down, things like that. So we give the user or basically the proxy for the user, which is in this case the microcontroller, we give it the ability to do whatever it needs based on these monitoring functions. And monitoring functions are around the output, whether it's at the correct levels and all that. It's around the memory of the memory inside the device, whether it's all correct or not. It's around the phase lock loop, whether it's locked or not. It's about the MEMS clock, the reference clock that's coming in. Is it locked or not? These are all the different things. So essentially, we are giving the user the ability to monitor the heartbeat and make sure that it's okay.
Yeah, and I think one of the examples you used is, for example, if the timing fails on the lane keep assist, then it will automatically flag to the driver, or you've got the ability as a developer to flag to the driver instantly that's not available now, so that they can go back to using level, yeah, whatever it is.
Yeah, yeah. Get your eyes on the road and start driving,
Exactly.
basically.
Yeah, that's the point of that, isn't it?
Exactly.
You've had, I think, yeah, you said you've sort of had customers talk to you, come to you looking for some of these features. What's been the feedback in terms, because I think you're pretty well advanced in some of these the design slots.
Yeah. So obviously, when we talk to automotive customers, they talk to us about the features. This started a couple of years ago. And when we started developing, it was with their input about what they wanted to monitor, what would help them design better automobiles. And so we're engaged with quite a few of them already. The cars which use this will come out either in late 25 or early 26 timeframe, the first cars. But then, of course, there's a whole bunch of designs that follow that come out later too. And the people who are more ahead in the game, there's obviously some regions which are ahead. There's obviously a category of car makers like EVs who are usually ahead than the more traditional ones. But we are seeing interest from all the different people.
Okay. A bit of context. Where does this fit in the SiTime business?
Good question. So we believe we are the only supplier who's 100% dedicated to timing. Timing has three major product categories. You have resonators, you have oscillators, and you have clocks. We've been doing MEMS resonators and oscillators for a while. This is part of the clock business. And if you remember, we acquired the Aura products way back in November of 23. This was actually started even before we acquired the Aura products. So it fits into the clocking side of the business. It's homegrown, i.e. developed by SiTime. We started work on this about 2.5 years ago. And that's where it fits basically.
And Piyush, what about the broader trends for the business in the industry? I mean, tell me a little bit about what you're seeing.
A lot of innovation going on, a lot of new use cases for electronics, a lot of things that people would not have done 10, 15, 20 years ago, and they're beginning to do that now. I mean, you're obviously seeing the trend in cars, just a lot more electronics, lane keeping assist, and variety of sensing and all that. So that's all there. But even if you go into markets like industrial, One of the places where we see a lot of new things happening, and where we can assist them by basically extending the battery life or enabling new features is in sensing.
Mm,
Uh, Sensors can be used for monitoring ocean floors. If there's like an earthquake, you can get early warning indications of tsunamis and things like that. You can be putting sensors deep downhole to measure a variety of things, temperatures for exploration, things like that. And 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 these are things where people are adding new features, making the sensors networked so that you can get more insight into what is happening in a particular area, for example.
mm.
And one of the benefits that we bring them with our timing devices is that because of the stability of our devices under extremes, whether it's vibration, shock, high temperatures, low temperatures, temperature changes, all that stuff, because our devices are very stable, they are able to extend the battery life dramatically. So instead of your battery life being 30 days, it might be 6 months, for example, because you don't have to wake the device up, the RF in the device up to synchronize to GPS or to basically transmit data as often and things like that. So that is one of the benefits that we are offering customers in some of these new applications.
So I think what you're saying is, the proliferation of electronics and sensing in particular are sort of a key part of what you're addressing.
Yeah, and that's in the industrial. I mean, there's other applications. There's a variety of places. In comms, obviously, we've talked about AI and how it's doing well.
Mm.
So just, proliferation of electronics, new features in electronics, and us being there to enable that as well as offer other basic benefits like extension of battery life and things like that.
Okay, well, Piyush, thank you very much.
Thank you.